This is a question from this year's GCSE 2023 higher maths paper. And every year they like to throw in a slightly harder question than others. And this question is probably at the end of really a stressful scenario. So it's kind of tough for the kids. And the question reads, each side of the regular octagons have side length of A. Find the area of the shaded shape in the form of P brackets 2 plus root 2 close bracket A squared, where P is an integer. Well, just so we understand what's going on, we want to work out this area here. And we've got side lengths of these regular polygons are all A's. So we've got a whole load of these A's splattered everywhere. I'm not really too sure what to do. Quite often, in order to work out an area of a difficult shape, we kind of simplify the shape into little bits. So I'm going to simplify it like this, just because it seems as if it's a sensible thing to do, but I'm not really 100% sure. So we're just going to try something. And we have something that kind of resembles a square in the middle and some other triangles. I don't know if it's a square or not. I don't even know if these are right angles or not. They look like right angles, but I don't know because this picture may or may not be drawn to scale. Well, it looks like it's to scale. We really have no idea. And if you kind of tilt your head, these can kind of look like right angles as well. But again, we're going to try and prove that and then see what happens. So if I pick any particular point, so let's say this point here, well, this is the interior angle of a regular octagon. And this is the interior angle of a rectangular octagon. And if this is an angle around the point, well, it must be 360, which means if I if I know the interior angle of an octagon, I can kind of like work out this remaining angle. So just find out whether it's 90 or whatever it is. So if you do know the angle of an interior angle of an interior octagon, well, that's great. You can just write it down. That should be fine. If you don't, then you'll have to kind of rely on the formula. And one format of the formula would be kind of n minus 2 times 180 divided by n, where n is the number of sides of the regular polygon. In this case, it's 8. So I have 8 minus 2 times 180 divided by n. Divided by 8. And then this becomes, well, 6 times 180 and divided by 8. And these would cancel to 3 and 4. And then 180 divided by 4, I can do 180 divided by 2, which gives me 90, divided by 2 again, which gives me 45. So this becomes 3 times 45, which gives me 135. So that means that this is 135 degrees. This is 135 degrees. And now we can work out this actual angle. So it'll be 360 minus 2 lots of 135, which gives me 270. And well, actually, it is 90 degrees. So it is a right angle triangle. And likewise, at this point, it's also 2 interior angles. So this is 90. So all of these are all 90 degrees. So all these little triangles are all 90 degrees triangles. And this is a square. Well, how is that helpful? Well, quite often when you have triangles and right angle triangles in them, or rather whenever you have right angle triangles, there's usually some sort of Pythagoras or trigonometry involved. So I can actually just fill in a few more A's here, just so we know exactly what we're talking about. And we're going to focus on just this triangle here. Now notice this triangle here, and I'm just going to draw a slightly larger version of it. Well, we have A and right angle triangle. Now, this is also an isosceles triangle, which means that this must actually be 45 and 45 because it's the same length. And this is 90, so these have to be 45. And when I actually bring this triangle down, well, you'll see what happens, that these two triangles actually form a square. And likewise, if I took this triangle and drew it like this, and this triangle drew like this, well, I have AA, which means that these 4 triangles, in terms of area, well, they become A squared plus A squared. So that means the 4 triangles have an area of 2A squared. And I'm kind of happy with that because when I look at the question, I've got loads of 2's and I've got an A squared. So it's looking promising. It's looking promising. I'm just going to get rid of this now, just so that I've got a bit more room. Now I've got to deal with the square itself. we've got to deal with the square itself. So if I look at the square, I'm just going to clear out some space. Well, I know this part is A. I know this part is A. But I've got this triangular part, and this is A and A. But this is a right angle, which means that this is A, this is A. In order to work out this part, I can now actually use Pythagoras. And Pythagoras would say, well, this length, this squared is equal to this squared plus this squared, which means that the length of that is the square root of A squared plus A squared, which equals square root of 2A squared. So that means that the side of a square is A plus A, which is 2A, plus this part, which is plus square root of 2A squared. Now, I can actually take this A squared out now, because these are multiplied together, and I can actually make that into 2A plus A root 2, because the square root of A squared is A, but the root 2 kind of still stays there. So that's the side of a square. And how do I work out the area of a square? Well, I multiply two sides together. So that means the area of a square, well, would be, well, 2A plus A root 2 squared. And then when we open up the brackets, well, I'm actually going to rewrite this into two brackets just so I can show how the multiplication works. 2A plus A root 2. Well, if I do this times this, well, I get 4A squared. If I do this times this, I get 2A squared root 2. If I do this, I get another 2A squared root 2. And then this times this, well, I get A squared, I get, well, root 2 times root 2 gives me 2, and then I get A squared. And if I gather up the like terms, well, I get 6A squared plus 4A squared root 2. We've got two of those, let's get 4 of those. So that's the area of a square. But I want the area of the shape. So I need to add up the area of the square plus those 4 triangles to give me the final answer. So I've got to add up these two together. Well, I've got 2A squared, 6A squared. Then the area of the shape would equal to 8A squared, 2A squared plus 6A squared, plus the 4A squared root 2. However, I wanted it in some sort of format of P brackets 2 plus root 2A squared. So I'm going to take out A squared, and funny, I'm going to put them at the back this time because they want the A at the back for some reason. So if I take out A squared, I get 8 plus 4 root 2A squared. So I've got the A squared sorted. But I also want 2 and root 2 here. And for 8 and 4, well, that means I can actually take out, divide by 4 for out and take it out. So I get 4, that leaves 2 plus, well, root 2A squared. So that means that P is equal to 4. And then, yeah, that's it. So again, quite a tricky question, especially when you consider that the students already been sitting in there doing a whole load of work already. And this is the last question that comes and kind of like, not really necessarily throw a spanner in the works, but it certainly makes them think a little bit harder.